Hello everyone and welcome to my video on the ellipse. This is for section 9.3 and in this video our skill objectives are number 1, to sketch the graph of an ellipse, number 2, find the equation of an ellipse, and 3, solve applied problems using ellipses. The conceptual objectives: derive the general equation of the ellipse, understand the meaning of major axis, minor axis, and foci, or foci. Understand the properties of an ellipse that result in a circle. And 4, interpret eccentricity in terms of the shape of the ellipse. Now let's start out by taking a look and reviewing the definition of an ellipse that we had from the 9.1 video. In this case, an ellipse is the set of all points in a plane, the sum of whose distances from those two fixed points is constant. Now remember in this case that the fixed points are called the foci or foci. And when we look at an ellipse, there's some features that you're going to need to identify. First up, the way we classify an ellipse is based on the major axis, which in this case is right here. The points that lie on the major axis are the vertices, which are at the end point of the major axis. Those two fixed points, foci, and then we have our center point. The center point is at the intersection between the major axis and the minor axis. So the major axis is the longer of the two axes. The minor axis is the shorter of the two. Also, they'll be perpendicular to each other. Now you're going to be asked to identify in terms of from the equation, and when we get into the equation in standard form, you're going to be asked to identify the center point, the vertices, the two fixed points, the foci, as well as the endpoints of both the minor axis as well. Another thing you're going to find in this is that we're going to be dealing with what's called the eccentricity, and we use the letter E for that. E is equal to C over A. And in this case, C represents the distance from the center point to each focus. So it's going to be this distance right there. That's C. A represents the distance from the center to each vertex. So this distance right here, that's A. And so you can see from this that C is always going to be smaller than A. And so for an ellipse, the eccentricity, the value of E, will always be a number that's between 0 and 1. Now what happens with this? As E approaches 0, that means that the foci are moving closer and closer to the center point, because that's going to mean that C, the value of C, is getting closer and closer to 0. And as that occurs, our ellipse is going to be more circular. As if that value of E gets closer and closer to 1, so what's happening there is that our foci are moving are getting further away from the center, and they're also getting closer to the closer to each vertex. In that situation, the ellipse is going to become more elongated, more like a cigar shape, if you will. Now, when we talk about an ellipse, we do classify it based on whether or not it has a horizontal major axis or vertical major axis. So when we have a horizontal major axis, like in this one, you can see it's more stretched out left or right, whereas if it has a vertical major axis, it can be stretched out up or down. So the standard form, the general standard form for all ellipses that have a horizontal major axis, they will be in the form of x minus h squared, that quantity squared, over a squared, plus y minus k, that quantity squared, over b squared, and that equals 1. When you have a vertical major axis, it's going to be x minus h squared, that quantity squared, over b squared, plus y minus k, that quantity squared, over a squared equals 1. So the key part, the first thing you're going to have to do is when it is in that standard form is identifying whether or not you have a horizontal major axis or vertical major axis. Because besides the center point, how you identify the vertices, the endpoints of the minor axis, and the foci are going to be different based on which type of axis you have. The general thing that you have on this, what you will always know on these things, is that when you're dealing with an ellipse, a squared will always be greater than b squared. The value of a is always going to be bigger than the value of b. And we know that also because of the fact that we've already talked about that the value of a is the distance from the center point to each vertex. That's a units. The value of b tells me the distance between the center point to the endpoint of each minor of the endpoints of the minor axis. Okay, so that's really what you're going to have on that. So the center point is just hk, and again, it's in the standard form. It's x minus h, y minus k. So the signs that you're going to find on h and k will be opposite of what you see in the problem. And then to get to the vertices, because it's a horizontal major axis, I'm just going to be changing the x coordinate. So it's going to be at h plus or minus a comma k is where each vertex is. So h plus a comma k and h minus a comma k would be the coordinates of each vertex. And the endpoints of the minor axis are going to be at h, k plus or minus b. So we're going to add and subtract b units from k to find the endpoint of the minor axis. The last thing we have is that the foci. They are the distance from the center to each focus is equal to c units. So, and they lie on the major axis, so the foci are going to be at h plus or minus c comma k. So that's for the horizontal major axis. Now you'll notice when we have the vertical major axis, I'm going to add a to the it's going to be adding and subtracting a from k to find the vertices, adding and subtracting b from h to find the endpoints of the minor axis, because in that case we're only shifting at the minor axis is going to be horizontal, and then we're going to add and subtract c from k to find each focus. Now the other thing you're going to notice on here, we've talked about how the distance between the center to each focus is c. And when we look at this equation up here, I have an h, I have a k, I have an a, I have a b, I don't have a c. Well, to determine c, there is a relationship that does exist between a, b, and c. And what you have on that is that a squared will always be equal to b squared plus c squared. That will always be the case. Now that looks very much like the Pythagorean theorem. Okay? Often they'll sit there and say they'll talk about it as c squared equals a squared minus b squared, just to put it into that form so you're solving for c. But again, you've got to be careful on this one because these are the letters that you see, that you normally see with the Pythagorean theorem, but it is very different from from the Pythagorean theorem. Okay, so that's the relationship you're going to have to go through to determine c when you have the equation in its standard form. Let's take a look at an example. In this case, what we want to do is we want to sketch 4x squared plus 32x plus y squared minus 2y plus 61 equals 0. Now, in this case, we're not in standard form. Very far from it. And the first thing I want you to realize with this, that yes, we're not in standard form, and in order to put it in standard form, we are going to have to complete the square on the x's as well as the y. So I have to complete the square twice in this problem. So the first thing I'm going to do, I'm going to group the terms with x together. So I have in parentheses 4x squared plus 32x. Close off that parenthesis, plus Now I'm going to have the y squared minus 2y in parentheses. And the other thing I want to do is I want to get that 61 over to the other side. So I I subtracted 61 from both sides. So I have that this thing plus this equals a negative 61. Now in order to complete the square, we recall that the coefficient on the squared variable does need to be 1. We're okay with this one. It's a 1y squared, but here I have a 4. So I do need to pull out the common factor of a factor of 4. And when I do it, I have 4 times the quantity of x squared plus 8x plus the quantity y squared minus 2y equals negative 61. Now we complete the square. Remember what's going to happen. I'm going to go through and do this inside these parentheses. I'm going to add half of 8, which is 4. So I'm going to add a 4 squared inside these parentheses. So I have 4 times the quantity x squared plus 8x plus that 4 squared. Plus, over here in this one, I'm going to take half of the 2 and add that. Half of 2 is 1, so I'm going to add 1 squared inside the parentheses. So I have y squared minus 2y plus that 1 squared. And that is going to equal the negative 61. Now I've added a 4 squared inside. That's 16, but I'm also have to multiply that by 4. 4 times 16 is 64. So by putting the 4 squared in this thing, I've actually added 64 to this side. So I need to add 64 over here as well. In this one, I put a 1 squared in, which 1 squared is 1. So for this one, this 1 squared has actually added 1 to this side. So I still need to add 1 over here as well. So that's why you see the negative 61 from up here, plus 64 because of the red, and plus 1 because of the blue. Negative 61, plus 64 plus 1, that's equal to 4. And this factors, again, remember, the only reason you complete the square is how these two things are going to factor. X squared plus 8x plus 4 will factor as the quantity x plus 4, that quantity squared. So I'll have 4 times x plus 4, the quantity squared, plus y squared minus 2y plus 1 squared will factor as the quantity of y minus 1. That thing squared equals 4. To finally put this into standard form, I just need to go through and get this equal to 1. Well, to do that, I'm going to divide by 4. So I'll divide everything here by 4. This 4 and that 4 cancel out. And so what I have in this case is y plus 4, that quantity squared, over 1, plus y minus 1, that quantity squared over 4, and that equals 1. Now, in this case, so what I have from this one, I can now say that my center point is at negative 4, 1. I know because the larger denominator is under the y, I have a vertical major axis I know A is equal to 2, B is equal to 1. Because remember, these values here, the A squared is 4 and B squared is 1. So the square root of 4 is 2, that's A. The square root of 1 is going to be 1, so that's B. The other thing I do need to find is I do need to find out what C is. And now on this problem, what I know is I know that C squared equals A squared minus B squared. So C squared is going to be 4 minus 1. C squared equals 3. So from that, I know, therefore, C is equal to the square root of 3, which is about 1.7 thereabouts. So what I'm going to do on this one, to sketch this, the first thing I need to do is I need to go and plot the center point. The center point in this case is at negative 4, 1. Well, I have this marked off. Each line represents 1 unit. So negative 4 is here, and 1 is right there. So there's our center point. The distance from the center point to the end to the each vertex is 2 units. And since this has a vertical major axis, I know I'm going to go 2 units up. So there's a vertex. And I'm going to go 2 units down. So there's that vertex. Okay. The next thing I know on this one is I know that my endpoints of my minor axis, the endpoints of the minor axis is going to be 1 unit to the left and to the right of that center point. So my center point is there, and now I'm going to move 1 unit to the left and the other left, and there we go. 1 unit to the left and 1 unit to the right. And that gets me the endpoints of my minor axis. And so right now I can actually draw the ellipse in this case. I know my ellipse is going to start from here. It's going to come down, go there, and like that. Pretend that's a decent ellipse. The only other thing I'd have to do is I would need to place each focus. And I know the focus is going to be about 1.7 units away. So my each focus is going to be, if I go about 1.7, this is at 1, so I'll be up at 2.7. Well, 2.7, let's just say it's going to be right about here. So there's one focus, and 2.7 is going to end up being right about there. So there's the other focus. So when I look at that, in this case, this is my major axis. Here's my minor axis. And then we've also placed the vertices and each focus. Make sure you're comfortable with everything I did here. If not, make sure to note it in your notes. And otherwise, let's go to our next example. In this example, it's going to be going the other direction. This time what we're going to do is we want to find the equation of an ellipse, but they're going to give us some information. For example, they're going to tell us that each focus, one focus is at the point 2, -2, and the other focus is at the point 4, -2. Also, they're to tell us that the vertices, one vertex is at 0, -2, and another vertex is at 6, -2. Well, the first thing I need to do when I'm finding the equation, I want to know what H and K are. I got to find that center point because the values of A and C and B are all based on are going to help us go through and identify, in this case, from that center point. Well, the center point is the midpoint between the two foci or the two vertices. So all you have to do is find the midpoint. Remember, the midpoint is the average of the x's and then the average of the y's. Well, in this case, the two y's are the same, so that's going to be -2. The average of the x's, 0 plus 6 divided by 2, right there, is equal to 3. So our center point in this case is 3, -2. The other thing I'll notice on this one, I notice that my y values are the same. What's changing are the x coordinates on my foci and my vertices. So that's telling me because the x coordinate is changing, I know I'm dealing with a horizontal major axis. So in this case, each vertex, the distance from 3, -2 to each of the two vertices is going to be 3 units. So in this case, I know A is 3. The other thing I know is that the distance from the center to each focus is 1 unit. So I know C is 1. And again, using the relationship that we have, that b squared plus c squared equals a squared, we can go through, plug this information in, and I know that b squared plus 1 squared will equal 3 squared. So b squared plus 1 equals 9. So in this case, I know that b squared equals 8. Now notice on here, I'm not finding out what b is. I really don't care what b is on this one. I just need to know b squared because I'm asked to find the equation. I'm not asked to identify what are the coordinates of the endpoints of the minor axis. I just want to find the equation. Since we do have a horizontal major axis on this one, the standard form for that equation is x minus h squared over a squared plus y minus k squared over b squared, and that equals 1. So now I know h is equal to 3, so I'm going to put the 3, this 3 is going right in for h. K is negative 2, so I'm taking negative 2 here and putting it in for k. So I have x minus 3, that quantity squared, in the top numerator here, and y plus 2, that quantity squared, in the numerator on this first one. The other thing that's happening is that this is actually 3 squared, so I'm going to make it look clearer. I replace a with, because a equals 3, I'm going to replace a with that 3. And b squared I know is 8, so I just put 8 in for b squared. And so the standard form for this equation comes out to be x minus 3, that quantity squared, over 9, plus the quantity y plus 2 squared over 8, and that equals 1. So this right here would represent the equation of the ellipse described right there. This does end, this is the last slide, but in terms of going through and doing the application problems, often what you're going to want to do with the application problems is you're going to want to have that center point be at the origin. So when they start talking about an ellipse on this one, when they go through and tell you the information, they'll give you information, but they're not going to say a specific point. They'll just tell you that, oh, the minor axis, which the length of the minor axis is equal to 2a, that length, that length is equal to a value. So you cut that in half, that's a. Or they'll tell you the length of the minor axis is going to be equal to a number. Well, the length of the minor axis is 2b, so you can divide that length in half and find that. But the key part when you're trying to find the equation, a lot of times they're going to ask you to find an equation of these things. If you're given a situation where they have not told you the center point, the key thing is make the center point equal to the origin. Let h and k both be 0. That can help you in terms of the application problems. So you'll see a couple in there, but they're not too difficult. And remember to make sure to ask questions as you go through this. So this does now conclude this video. I hope that it's answered your questions on some of these things. Go back, look over it, make sure you're comfortable with my calculations. And if so, then you should be okay, and we'll see you in class. If not, spend a little bit more time taking a look at the calculations, make sure you're comfortable, or even look at some of the examples in the book, see if those help you out as well. So with that, I'll see you in the next class. Bye now.